Good day, ladies and gentlemen. This is Sarah van Grinnen, aka Mr. VG, and man, what a beautiful and amazing day to be doing mathematics. I hope that your mind is switched on, you are switched on, you're ready for this amazing rule that will infiltrate all of derivatives, all of functions, because it shows that how you can derive a function within a function. So when we talk about the chain rule, ladies and gentlemen, it is super important that you are able to do this. The chain rule is the rule that basically tells us if I've got a function inside of another function, how do I derive it? When I look at this, the rule basically tells me if I want to determine dy over dx, I must derive the outside function and multiply it by the derivative of the inside function. So in other words, I derive the outside function, but keep the gx inside of that derivative. Then I multiply it by the derivative of the inside function. Now this is a bit of a weird one to get used to, but once you get used to it, it's actually super fast. But I don't want to work with outside and inside functions necessarily. So what I want to look at is, remember the previous video on decomposing functions, I talked about junk. So I'm going to now see this as being f of junk. So the g of x is just basically the junk. Just a nice way of saying the inside function. If I look at deriving this as if it's dy over dx, basically I'm going to say take the derivative of f and substitute your junk into that derivative. And then multiply that by the derivative of the junk. That's exactly what we wrote with the fx and the g of x there in the middle in the blue, but just put in another way. So let's have a look at a function like y equal to cos of 2x minus 1. What is f and what is junk? Well, it's easy to see that the 2x minus 1 is the junk, and then I've got f of junk. So in other words, f of x is equal to cos of x. And the junk is 2x minus 1. Remember, now we actually need, for our rule, we need the derivative of both f and of the junk. So the derivative of f is negative sin x, and the derivative of the junk, and I'm going to write it dx of junk, that is simply 2. Writing out my rule, I've got dy over dx being f accent of junk minus dx of junk. So the derivative of f is sin, negative sin. I'm just leaving brackets there because I'm going to put the junk in there. I'm not going to put the x in there. Remember, you need to put the junk. So you've got to put that junk inside of the derivative of f. And then I'm going to multiply it by the derivative of the junk. Remember, I got that answer there as being 2. So placing that junk inside of the derivative, I've got negative sine of 2x minus 1. And don't forget about the times by 2. And there I have derived that original function. Now you go and derive y equal to ln of tan x. When I look at this, f is going to be my ln function, ln of x, and then the junk is going to be tan x. So in other words, I can derive f accent or fx, and I've got 1 over x, because that's the derivative of ln. Then, if I take my junk x as being tan x, the derivative of junk, well, that's sec squared of x. So writing out my rule, dy over dx, the derivative of f is going to be 1 over junk, because I'm placing junk into x, multiplied by sec squared x. But what is junk? I can't write junk for the examiner. So I'm going to say that's 1 over tan x times by sec squared x. As simple and as easy as that. Now you can go and simplify that further. I'm not saying that you can't, but I'm not going to focus on that in this video. When we have a look at y equal to 4 sine e to the x squared, I want you to first decompose it for yourself mentally or on your paper, and then you go and try it, okay? If you look carefully at this, there's actually 3 functions, okay? I've got an fx, I've got a gx, and I have an h of x. You've got to kind of be careful of that. First of all, I have the y equal to 4 sine of something. Then I've got y equal to e to the something. And then I've got a y equal to x squared. So my innermost function is going to be y equal to x squared. But our outermost function is going to be y equal to 4 sine x. That is f. Your e to the x is going to be g. And then your x squared is going to be your innermost function. So how do I apply the derivative of this? Okay, looking at that little diagram I drew there, before you've got y equal to f of g of h of x, I am just telling you that I've got x squared being substituted into e to the x, and e to the x squared being substituted into 4 sine of x. Now, if I've got y equal to f of g of h of x, like I wrote there, let me go back a little bit in my writing. If I want to derive this, okay, so dy over dx, I know I've got to derive my f, okay, my outside function. But now I've got a bit of a problem, because the chain rule says I must now derive the inside function. But now the inside function is also a composite function, which means if I want to derive that function, I know that I've got to use the chain rule, which means I'm again going to derive my g and multiply that by the innermost junk, which is h of x, the derivative of h of x. But I can't forget about that f accent of the big junk, the g of h of x. So go and try and derive this one yourself first. If I look at this, I've got the dy over dx, which means I've got to first derive the sine, then the e, and then the x squared. So if I derive the 4 sine, I'm going to get 4 cos of junk. So 4 cos of something. And then I'm going to multiply that by the derivative of e to the something, which is just e to that something. And then I'm going to multiply that by the derivative of your innermost function, the 2x. So where did we get the 2x from? Remember, that was from deriving the x squared. Where did I get the e to the x squared from? From deriving that inside of the sine of x. So therefore, I have 4 cos e to the x squared times by e to the x squared times by 2x as being my answer. Not in the most elegant or so way of writing, but this would be my answer for the examiner. I hope you enjoyed this video, ladies and gentlemen, and that you can go now and practice the chain rule. This is Mr. VG signing out. Watch out for my next video where I'm going to do a few combinations of the chain rule, the product rule, the quotient rule, so that you understand that the chain rule will actually infiltrate all the other derivatives. All other differentiation will be infiltrated by the chain rule. So have an absolutely beautiful and amazing rest of your day. Enjoy your evening and keep yourself safe. This is Mr. VG signing out. Cheers.